This problem is the runner on a wooden plank problem. The runner starts out on one side of the plank and runs to the other side of the plank. We are asked how far do they end up from their initial starting point with respect to the ground. This center of mass problem has a system of two objects. Since there's no external force on the runner plank system, the center of mass is going to stay the same both at the beginning and the end of the problem. The center of mass in the initial position is due to the weighted sum of the centers of mass of the runner and the plank. The center of mass of the plank is in the center of the plank. The center of mass of the runner is the runner at the edge of the plank. And the total center of mass is somewhere in between them. I drew it a little bit closer to the center of mass of the plank because the plank is heavier than the runner. In the end, the runner is on the other side of the center of mass, which means that the plank needs to move back to maintain the location of the same center of mass. So let's actually work out the math of this problem, the key point being that the center of mass does not move. The initial situation, we have the person who weighs 75 kilograms. We're going to define their x position as being 0. And this is 0 in the reference frame of the ground. And so we've got 75 times 0 plus 100, which is the weight, 100 kilograms, of the plank, times 2, because the middle of the plank where the center of mass is located is 2 meters from 0. And then we divide that by the total mass, which is 75 kilograms plus 100 kilograms, and we get that the center of mass is 1.14 meters, which is in between 0 and 2 meters. Now we do the final situation. The runner is going to be at some position D from the initial position 0, and the plank is going to be at D minus 2, since the center of mass of the tank is now going to be 2 meters behind the runner. So we write 75 times D plus 100 times D minus 2 divided by the sum of the two masses again. And the key point is that the final center of mass and the initial has to equal the initial center of mass, which has to equal 1.14 meters. And so when we solve for D, we end up getting that D is equal to 2.3 meters.